Hi guys, this is Mrs. Gastler, and in this video we're going to be talking about graphs. Not how to make a graph, but how to use a graph in physics class. This works for both AP Physics 1 and AP Physics C and loads of other courses. Other AP Physics courses, other courses in general. Anytime you're trying to find a relationship, you can use this information. So, we'll start at the top. We're going to be interpreting, analyzing, and using graphs. This is actually a pretty high-level skill to be able to do. In physics class, we like to discover some relationships, and so we need to be able to look at these graphs to be able to get that information out of them. What we're going to be doing at some point in time, either before this video or after this video, you're going to complete an activity where you have to practice graphing and practice interpreting graphs. This will help you do that if you need it. The most important thing to remember about drawing a graph, most students who have any kind of trouble with graphing need some more help than that. But if you think you're pretty good with graphing, the most common mistake that pro graphers make is in their title. The title of your graph, whatever's on the y-axis, comes first. Okay, however you're graphing it, whatever is on the y-axis comes first in the title, always y-axis versus x-axis, okay? So that's, it's a little mistake there, but it is good to make sure that you have your title correct. If you need any other assistance with scaling or putting points on it or drawing a best fit line, remember that the line doesn't touch. Oh, maybe that's the other most important thing. Don't ever, never ever, connect the dots, okay? You can connect dots in Algebra 1. You're not in Algebra 1 now if you're taking AP Physics, okay? All right, so here's what we're going to do. We're going to look at some relationships. There's probably a poster like this in your classroom also. So we're going to look at 6 possible graphs that you might see, 2 of which are very similar. One of them goes like this, and the other one goes like this. See how similar they are? They're beautiful, okay? Actually, they're all kind of similar. The next one goes up and curves. It curves upward. Notice how it curves upward. The next one curves downward. And then we have one that curves downward like this as it goes. Well, it curves up as it goes down, whatever. We'll come to that later too. And one that goes down real fast but curves out straight like that. Okay, so those are the different graphs you might see in some labs in physics class that you're going to need to interpret. Okay, so when you see these graphs, we are trying to find out what the relationship is. We call these 2 relationships linear, these first, because they are aligned. These are linear relationships. We call this one positive linear because it goes up. We call this one negative linear. Whoops, I pushed the, there we go, negative linear because it goes down, but they're both straight, okay? If you have a straight line, then you are probably dealing with a linear relationship, okay? The next 2, well, the next 4 curve. 2 of them go up and 2 of them go down, okay? This one here is called an exponential relationship. Exponential, it curves upward. Okay, it curves upward. It's like part of a parabola. It actually is part of a parabola. This next one here, it's going up, but it curves downward. So I would say that this one kind of levels off. It doesn't actually ever level off. It might, but we can use those words. I like to call this one a square root. That's what I call it. There's actually, if you see this kind of graph, something else is actually true. It's actually exponential, but it's flipped. Hopefully you can see that they have some sort of relationship there. So we'll come back to that star later. We'll put a little star down here. Those are related. This one coming down like this right here, this is called inverse. Inverse. Okay? It curves downward. It's a gradual, kind of a gradual drop off at the end here. And this one right here is called inverse square. And this one, the difference between the inverse and the inverse square is that this one is a fast drop. Okay, see how this one kind of gradually, well, it kind of gradually changes. This one is like, and then it starts to turn, okay? That's how you can tell by looking at those. Inverse, the difference between inverse and inverse square, it's kind of hard to see. You have to make sure you get enough data points from your lab activity in order to be able to determine whether it's inverse square. A note also, 10 points on a graph are kind of the minimum. I don't think you can see my writing that. That's kind of the minimum. 15 would be okay. It would be better. You would have more data to look at, but if you can't get at least 10, you may have a hard time, especially when it comes to inverse versus inverse square, okay? So that's the interpret part. Once we've identified the relationship, actually keep those in the picture there, then the next thing we're ready to do is analyze the relationship, okay? So when we know what we have on the x and we know what we have on the y, analyzing it is the next part, okay? So this graph is going to have the form of y equals mx. Maybe it starts at 0, in which case it would be y equals mx. Maybe it starts up higher, in which case it would be y equals mx plus b, okay? This one has the same thing, except in this case, m is negative, so we'll just put a little negative there, right? Okay? Maybe the negative is part of it, maybe it's not. This one here on exponential, like I said, it's a parabola. That's y equals kx squared, where k is just some constant that tells you some information about what's going on. Square root, okay, one way to write it is like this with the square root over k and x. And another way, and this is why I said it's like exponential, is you could write it y squared equals kx. But this is a weird way to write it, and that might feel unnatural in your head to write an equation with a square on the y, and that's okay. We're going to talk later on about something called linearization, which will help make this be okay in your head. It'll be weird, but it'll be okay. For inverse, we have y equals 1 over x. It's like the inverse of something. Whoops, not 1 over x, but that k, because there's always a constant involved. See, here we have m for the slope. K is just it's a constant that goes with the graph. K here as well. And then for our inverse squared, k over x squared. So that squared is on the bottom there. That's what makes it drop off so fast like that. Now, when we use these graphs, what we're doing is we're going to insert variables for y and x according to the lab. So let's say that you were doing a lab over, let's pick some random thing, leaves per tree, okay? So maybe you've collected some data and you want to think about how many leaves there are versus how many trees there are and what the relationship for the number of trees you have and the number of leaves that you're going to have to rake. Maybe you're raking leaves, okay? And so you are changing the number of trees, so your y value is tree, and your x value, no, I'm sorry, your y value is the leaves, and your x value is the tree, okay? So when you make your graph, maybe you find out that it is exponential, okay? Maybe it's exponential. The more trees you have, you get a lot more leaves really fast. So if it's exponential, then our equation is y equals kx squared. So leaves equals whatever this constant is times tree squared, okay? Because you can do that. You can stick words in for y's and x's. Now this k value is going to have some meaning, and maybe we have to do a lot more experimenting with our trees and leaves. Maybe we just need to talk to our teacher about what the accepted equation is. But this constant right here, not exponent, this constant means something, and that's what we're really trying to find. Okay. Once I've done that, I have an equation that I can use to do all sorts of things like predicting a value or measuring another tree. I could put more data on there. So that is how to interpret, analyze, and use graphs. Thanks for watching.